Colored pens up. Number 1, what's the equation? Start with John, Alexandra, Edgar, and then Michaela. John, what'd you get?
I got y plus 4 equals negative 1 or negative, negative 1 times the quantity of x minus 2.
Okay, Alexandra, what'd you get?
Y plus 4 equals negative 1 times quantity of x minus 2.
So I think you agreed exactly with him. Who would I say was next? Edgar, go ahead.
Y plus 4 equals negative 1 times the quantity of x minus 2.
So once again, you agree, Michaela?
Y plus 4 equals negative 1 times x minus 2.
So all 4 people agree. That was one of the equations. That was the other one. Now, I'm really impressed that all 4 of them said negative 1 times the quantity. That was really good, and John had started that off. That was fantastic. So here's the one that all 4 of my volunteers had said. But the second one was this because there was another point that you could have used. Either one is equally correct. Number 2, convert the equation. What will it become? We've got Valerie, Stephanie, Dalton, and then Kadir. Valerie, what'd you get?
Y equals negative 2x plus 9.
Okay, what'd you get, Stephanie?
Y equals negative 2x plus 9.
So you were in agreement, Dalton.
Y equals negative 2x plus 9.
Once again in agreement.
Y equals negative 2x plus 11.
Plus 11. So there is some disagreement, and I heard some discussion of some other people saying it was something else, and some people were trying to prove or disprove. It comes out to y equals negative 2x plus 9. So I'd like to talk about number 2 because number 2 is a type of question that, if you can be successful, demonstrates that you understand the connecting pieces from the previous lesson to the lessons before. So what I've asked you to do is convert the equation from point-slope form, which is this, to slope-intercept form. So I'd like it to turn from this into this. So give me a thumbs up if you were successful. Good, a lot of people. Put your thumbs down. So now the question is how, because there's actually a whole bunch of different ways to do it. So we're going to start with Fung, Kalasia, and then Danielle. What did you do?
I did strip farming first, and then I subtract those ones.
Okay, so you distributed, and you get y plus 1 equals negative 2x plus 10. And then what was your second step?
Then I subtracted 1 side.
Subtract 1 from both sides. This disappears, and you get y equals negative 2x plus 9. Outstanding. Kalasia, what did you do?
I looked at the equation. The slope was negative 2, so I did that. And then I plugged in the numbers, and I solved it, and I got 9.
Okay, so hold on. Let me come over here. So you knew that the slope was negative 2 because it's right there, right? Outstanding. And then you use this form. So, and then you plugged in one of the points. What point did you plug in?
5 and negative 1.
Very good. So that's the advantage of point-slope form, is that built in is the slope and a point. The point is the opposite of this, so it's 5, comma, the opposite of that, negative 1. 5 comma negative 1. So she did something brilliant. She put the negative 1 in place of the y. So you got negative 1 equals the slope, negative 2, times 5 plus b. And then she solved for b, and she ended up with 9. And so she got y equals negative 2x plus 9. So 2 totally different approaches with the same result. The result we were looking for was this. Anybody do it any differently? Danielle, you were next. Which way did you do it? I'm sorry? Feng's way? You did it just by distributing and just converting it? Anyone do it a different way? There's a lot of people who had success. That's very good. Okay. Any comments or questions on how we did this? Dalton? Okay. Comments, questions on anything? Good. Put the warm up to the side. Today we introduce the third, and for you guys, final form of linear equation. You've already learned slope-intercept form. You learned recently point-slope form. Today you learn standard form. One idea that I've been trying to get across to you is the idea that it's really the same thing, just looks a little different. I tried to get this across to you by using the analogy of money. And this is now like the 10th time I'm using this concept of representing a dollar using different methods. 4 quarters is $1, 20 nickels is $1, a dollar bill is $1. 3 different ways, same value. So now we're introducing another form. It's just another way of representing a linear equation, but it still has the same value. Each of the 3 forms has advantages and disadvantages. Slope-intercept form, the first one you were introduced to. You're supposed to have mastery. Slope-intercept. Which intercept is in the form? Slope-intercept form. Because it's called slope-intercept. Alexandra? The y-intercept. So the advantage of slope-intercept form is you immediately get the y-intercept and you immediately have the slope. Point-slope form. Point-slope. What information is immediately available from point-slope form? Dalton? Yeah, a point on the line and the slope. Point-slope form's advantage is that it's really easy to write an equation in point-slope form. Because all you need is a slope at any point. That's why it's so easy. Today, standard form has different advantages. So here's what standard form looks like. Notice the capital letters. Capital AX plus capital BY equals capital C. So these letters, the A, B, and C, are different than any letter B or A or C that you've seen in the past. So, one of the advantages is you already know. We learned it way back in chapter 4 when we were graphing using intercepts. When a linear equation is in this form, it's really easy to graph because it's so easy to get the intercepts from it. So that's one major advantage. Here are some other advantages and details. The slope will always be the opposite of A over B. So whatever numbers are in these positions, you put those numbers together and that becomes the slope, or the opposite of it becomes the slope. So for example, if this is a 10 and this is a 2, 10x plus 2y, then the slope would be you put A over B and then flip the sign. So A is 10, B is 2, then flip the sign. Put that in simplest form. What does it come out to? Shannon? -5. So you can easily find the slope from this form. So that's another advantage. Now there's a couple of rules with standard form that didn't exist with the other forms. Here's the first rule. A may not be negative. And I'm going to teach you how to deal with it. So you don't have to stress yourself out. But A may not be negative. Second and final rule is A and B must be integers. Can someone give me, several people give me examples of integers? Like, what's an integer? John and then Kadir. John, give me an example of an integer.
A squared
That's not an integer actually at all. I try in my class never to tell students that they're just kind of flat out wrong. I try to encourage, but unfortunately that is just flat out. No. So that's okay because he doesn't remember what an integer is, but that's why we're doing this right now. So give me another example. 2 is an integer. Give me another example. Jumar? -5 is an integer. Give me another example. 10 is an integer. Give me another example. Edgar? 69. Good. Now give me an example of something that's not an integer. Something that is not an integer. Michaela and then Alexander. 2 squared. Well, what is the value of 2 squared? 4. So that's really kind of an integer. You're right. 2 squared is exponential form. Alexandra? 2/5 is not an integer. What do we call 2/5? It's a fraction. Another example of something that's not an integer? Wow, nobody can follow someone else's example and then come up with their own example? Okay. 3a is not an integer, you're right. 3a. But someone give me just a number that's not an integer. A number that's not an integer. Matthew? 0.2 is not an integer. So when we write standard form, a must be a whole number and b must be a whole number, and they can be positive or negative, although we already learned that a cannot be negative. Okay? So those are rules that you have to follow, and we're going to talk about them. Now, the next page is going to be used to help you try and get a big picture idea. So I do not want you to write anything. Everyone can put your pencils down. And you just need to look. So, I'm introducing standard form. We introduced point-slope form last time. So everyone's eyes should be up here. An equation of a line can have many versions in standard form, can have many different versions in point-slope form, but only one version in slope-intercept form. So I want you to look at what I have right here. This is it. This, if you can look at this and understand, then that means you can demonstrate your understanding of everything we've been studying since the beginning of chapter 4. Can someone tell us what form of an equation is this? What form is that? What form is that, Extol? There's no such thing as y-intercept form. There's 3 forms that you've learned. In fact, they're right there on the whiteboard. So one of those 3 is what I'm looking for. Chris? Standard form. You should have been able to do that because that's what I just demonstrated. What form of an equation is this one? Extol? Standard form. What form of an equation is this one? What form is that one, Fung? Point slope. What form of an equation is this one? Sebastian? Slope-intercept form. So now we have a picture here. Which one of these equations matches this picture? Which one matches the picture? Don't write anything, but which one matches the picture? Chris, John, Dalton, and then Michaela. Chris, which one? All of them. Okay, what were you going to say, John?
The last one.
The last one, okay. Dalton?
4x plus 3.
Okay. So you think it's the second one. Okay, Michaela? The second one? Yeah. No, it's actually all of them. This is the whole point, and this is the piece that many of my students don't get, and I'm trying to help you along. Honestly, you should have discovered it along on your own. But these 4 equations all represent the exact same thing. What's the slope of the line? Someone tell me the slope without having to do any work whatsoever. What's the slope, Sebastian? How'd you do that so fast? Yeah, it's right here. Boom, there's the slope. Boom, there's the slope. You got 2 different ways to find it. Now you have a third one, right? A over B, and flip the sign. A over B, flip the sign. So the slope is exactly the same for all four equations. How could I get the y-intercept? Can someone tell me what the y-intercept is of this graph? What's the y-intercept? 1, 2, 3, 4, 5, 6, 7, 8 people. Only 8 people can find it, maybe because you don't know what I mean by y-intercept. What's the y-intercept? Ballard? 4. How'd you figure it out? That was a great explanation. She looked right here, boom, that's the y-intercept. Someone give me another way to find the y-intercept. What's another way to find it, Matthew?
For slope, for slope intercept form,
Which equation? 1, 2, 3, or 4? Good. And so that's called slope-intercept form, which you already said. So what do I have to do to get the y-intercept? Yeah, it's right there. Give me another way to get the y-intercept. That's 2 ways. Give me another way to get the y-intercept. If you're not trying, then you're not being a part of my class. What's another way to get the y-intercept? Kadir?
point slope form, you could try to make the y by itself. So you should possibly plus 2 on both sides.
Okay. Well, let's actually see what happens when we do that. So distribute, just like we did during the warm-up. Y minus 2 equals negative 2/3 x plus 2. Add 2 to both sides. That cancels out. We get y equals negative 2/3 x plus 4. Wow. What? Look at that.
I don't believe it.
It came out to this. Wow. And yet there's yet another way to get the y-intercept. What's another way to get the y-intercept? And it goes back to chapter 4. What's another way, Alexandra? Hold on. I want everyone to hear what you're about to say because I know you're going to say it right.
You put the 0 in the x spot x.
Which equation? First, second, third, or fourth?
First.
First equation. Good. And what do I do?
Put a 0 in the spot.
Good. You put a 0 in place of the x, so that basically disappears. 3y equals 12. Wow. Y equals 4. It's magical. Now, what if I did the same thing with this one? Let's see what happens. I put a 0 here. That will disappear. I get 6y equals 24. And whoa! I get 4 again. Does anyone see a relationship? Does anyone see a relationship between this equation and this equation? Anyone notice anything about those two? Notice anything about those two, Davis?
That it's practically everything's times 2.
Not just practically, that's exactly what it is. Everything was times 2. So now watch, everyone pick up your pencil. Davis leads us into example number 1. Now, example 1, standard form. The first thing we want to be able to do is write an equation in standard form or be given an equation and rewrite it as another version. I just showed you that 2 versions were the exact same line. Davis just told us that it was because the second one was double the first one. Well, that's actually the technique we're going to use. So, you don't have to copy the instructions, but of course you have to read them clearly. And it says, write 2 equations in standard form that are equivalent to the given equation. So there's a given equation. So I want another version of it. So it's very simple. We multiply everything by some number from our brain. So this is how you demonstrate. So what number could we multiply the whole equation by to get a new equation? What can we multiply by? Valerie? Times 2. Might as well keep it simple. Multiply times 2. So that'll be 9 times 2, negative 36 times 2, and 27 times 2. And so we end up with 18x minus 72y equals 54. And now I have an equivalent equation. And if I graphed them, they would both be exactly the same. Xiomara and then Dalton. We're getting to that in a second. So we are asked in the instructions to write 2 new equations. So we wrote one of them. The other option is, if we can, you can divide. But you have to divide if dividing is appropriate. So Xiomara, what gave you the clue that dividing might be good in this case? Yeah, all of the numbers are divisible by 9. So if we divide by 9, we will get another new equation. 9 divided by 9 is 1. Negative 36 divided by 9 is negative 4. And 27 divided by 9 is 3. And we have yet another standard form equation. And the point is, or the biggest point, is that this is equivalent to this, equivalent to this. Goes back to my money analogy. That's 4 quarters, that's 20 nickels, and that's 10 dimes. 3 different ways of representing the same thing. Does anyone have any questions about how we do this? So now we need to also learn how to follow the rules. So, part B, we're given this equation. We are asked to write 2 standard form equations, but we also have to follow the standard form rules. And the standard form rules say that A is not allowed to be negative. So, how can we change it so that it becomes positive? What can we do? Sebastian?
Times it by a negative number.
Very good. By what number would you like to start with?
Negative 2.
Negative 2. Wonderful. So if we multiply by a negative number, the negative will flip all the signs. So we're basically flipping all the signs and then multiplying by 2. So the A will become 14. The B will become negative 12. And the C will become positive 26. And so now it's in standard form because A is now positive. Comments or questions on how we did that? Kadir?
Did you also do the negative 1?
So let's do another one and follow Kadir's suggestion. If we just want to flip all the signs without changing the number or the numeral, then we could just multiply times negative 1, and that will accomplish the same goal, just flip all the signs. So this will become 7x minus 6y equals positive 13. Does anyone have any questions or comments on how we did that? The last rule was the one that we struggled with because we didn't know what an integer was, but now we remember. So here's an equation. It looks like it's in standard form, but it's not because A is a fraction and A has to be an integer. In fact, it has to be a positive integer. So we have to be a little more thoughtful about what to multiply by so that the A turns into an integer. But it's actually not hard. There is a number that we could very easily multiply by that will turn all of these into integers. What could we multiply by? Chris? Yeah, if you multiply by this denominator, the denominator disappears. So if we multiply times 8, this 8 will cancel that 8, and we're left with 3x. But now we have to multiply the 8 times this, so that's minus 16y equals, and now this 8 will cancel that 8, and we're left with negative 1. And now, these two equations are equivalent equations. Questions about how we did that? What else could we have multiplied by? Oops, excuse me. What else could we have multiplied by? Xiomara? Yeah, any multiple of the denominator will accomplish the same goal. Multiplying by 16 is basically canceling out the denominator and multiplying the numerator times 2. My students who were in my care class this morning, this is what you saw this morning partially. That becomes a 1, that becomes a 2. That's what we worked on this morning. So that's exactly what's going on here, is we're doing some fancy canceling to accomplish our goals. So this becomes 6x, and then the 16 times the negative 2 is minus 32y, and then the 16 times that will become negative 2. Does anyone have any questions on how we did that? Any questions on any of these? Okay, so it's a good news, bad news thing. Hopefully you feel somewhat confident and comfortable. The bad news is that was the easy stuff of the day. So now let's work through some more challenging questions. And questions that actually involve some thought. You're going to have to reach back into what you've learned in the past. Try and combine ideas from the past. We have a number of different choices, and here's where, again, my goal is for you to understand standard form, but the bigger goal is for you to understand everything we're doing. And to understand everything we're doing, it's important to be able to make connections. So I'm asking you to write a standard form of an equation. Have you ever been asked to write an equation in a different form where you were given this information? Slope-intercept. Any other situations you were asked to do? Point-slope. So you were actually asked to do both of those things given that information. Now I'm asking you to do standard form. So we could go directly to standard form. We could write a different form and convert it. We have a lot of different choices. For the first one, we're going to go straight into standard form. The reason is we're given the slope. The slope is negative 1/2. We were told at the beginning that the slope will always be the opposite of A over B. So here's standard form. AX plus BY equals C. And we know that the slope is negative 1/2. So here's what I want you to think to yourself. Negative 1 over 2. What number would have to be here so that when we put it here, it became negative 1 over 1/2? What number would have to be in place of A? Dalton? A 1, that's right. It would have to be a 1. So this is really 1x plus I'm sorry, it might not be plus. Let's back up a second. What number would have to be here so that when I plugged it in here, this became negative 1/2? Sebastian, see? I'm sorry? You're close. If I put a negative 2, that means that it will be 1 over negative 2, but then I flip the sign and it becomes positive 1/2. So what number would have to be here so that when I flip the sign it becomes negative 1/2? Positive 2, that's right. So this would have to be positive 2y. And the only thing that's missing is the c. Any ideas on how we could find it? How could we find it? Got 5 light bulbs, 6 light bulbs. We'll start with Fung, then Stephanie. Okay, what were you going to say? Very good. So you both had the same thought. That's outstanding. We have this ordered pair right here. And we have an x and a y. If we plug those numbers in for x and y, we can solve for c. We've done this process before when we use slope-intercept form. So it's the same process, just different form. So now we're going to plug in. We've got 1 times negative 3 plus 2 times 4, and that equals c. So what is the value of c? Shannon? 5. Very good. So now we are ready to write our standard form equation. 1x, we just write x, plus 2y equals 5. Now I just need to check and make sure my a is not negative and make sure both of these are integers. They are, so we're done. Does anyone have any questions on how we did that? Dalton? Well, I'm asked to write a standard form of the equation. So we wanted an equation with x and y. Okay? So once we found out c, Shannon helped us with that, we found out that c was 5, then we plugged it in here to complete the equation. Okay? I'm sorry if I went too fast with that. Does anyone else have any questions about that? Okay? You don't have to write, you of course always read everything, but you don't have to write the whole instruction, just write the basics that you need. So before we actually attempt B, let's compare B with A. What's the difference between the two questions? What's the difference in your opinion? Extol? That's outstanding. I couldn't have said that any better. That's exactly what I was actually thinking. Was that in A, slope was given to us. In B, it doesn't give it to us. So is that a problem?
No.
Why not, Sebastian?
Because you find slope by slope.
Yeah. And I love how quickly he made that jump. Because that's how quickly everybody else should be able to do it too. Oh, I don't have the slope, but I have 2 points? Oh, so that's no big deal. I just use the slope formula. And that's how quickly it should happen for you. So the first thing we'll do is label, just like we were taught, x1, if we do it correctly, x1, y1, x2, y2, and use the slope formula. M equals 9 minus 2 over 17 minus 8. What is it? 7/9. Slope is 7/9. So now if we think about standard form again, standard form, the slope will be the opposite of A over B. And here is standard form. But now we know the slope is 7 over 9. So what number, and this is, you have to kind of go through the process because it does get confusing. What number would have to be here and what number would have to be here so that when I plugged it into here, it came out to positive 7/9? What do you think, Davis?
A would be 7 and B would be -9.
Outstanding. That was fantastic. So if we put a 7 here and made this -9, then when I plug them in, that becomes positive because this means we flip the sign. This is 7, -9, and then flip it, it becomes positive. That was outstanding. But again, we don't know C, so we have to find C. But no big deal because Stephanie and Fung taught us how to do that. We have 2 points to choose from. Which one do you think we should use? Which point should we use, Michaela? Why? It's easier. That's my instinct would be that's easier. Numbers are smaller, so we plug in. 7 times 8 minus 9 times 2, and that will be C. I don't know if I can do that in my head. What do you get, Danielle? 38?
It's 30.
8.
It's 30.
56
18
minus 18 is 46, 38. So C equals 38. C equals 38. So we get 7x minus 9y equals 38. Now, I'm not trying to imply in any way that this is easy. I don't think this is simple. You got a whole bunch of different things going through your brain that you got to keep straight. But if you think things through and use techniques that you've already learned, then you can have success. Ziamara, then Dalton, then John.
I don't understand that this is negative.
Yeah, it's challenging because of the negative sign, right? So what if I took that away? What if I said slope is A over B? And slope is 7 over 9, so what's A? 7, because it's right there on top, right? And what's B? 9, okay? But there is this negative there. So what that means is we're going to flip the sign of one of these, the top or the bottom. So one of these has to be negative to flip the whole fraction to positive. Okay, so again, think of it this way. If it was like that, this would be 7 over 9. But it's like this, so it has to be negative 7 over 9. Or 7 over negative 9. Here are the choices. This can either be 7 over negative 9 or negative 7 over 9. Both of those become negative fractions. That's the way negative fractions work. But Davis's way worked better because if we choose this one, then A is positive, which is what we want, and B becomes negative. We don't want A to be negative. It's a lot to take in, Zumar. There's no two ways about it. You're going to have to give it some time to sink in. It's going to require some thought. It's going to require concentration. You're going to have to think carefully. Okay, wait, what is A and what is B? You're going to have to think about it. Okay? Let's see how you do on your own, and then we'll move forward. Checkpoint number 1, write standard form of the equation. your equation? Keeping in mind that there's many possibilities. Start with Shannon, John, Alexandra, and then Dalton, and then Sebastian. Shannon.
5x plus 8y equals -14.
Okay, what'd you get, John?
10x plus 24y equals 34.
Okay, so we have a big difference.
5x minus 8y equals
Okay, so that's also different. I forgot my order. Dalton,
5x plus 8y equals -14.
someone said that. I think Shannon said that. Who was next? Go ahead, Sebastian.
5x plus 8y equals
So 3 people agree on that one. Danielle, what did you get? So we have 4 people who think that's the right one, and that's the one I got. But before you mark your paper, it could be the same equation, but you could multiply all the numbers by 2, by 3, by 10, by 20, by 50, by 100, by 1,000. So if you have 10x plus 8y equals negative 28, that's the same thing. I'm sorry, 10x plus 16y equals negative 28. That's the same thing. So John, something about yours sounded a little strange. You said 10x, and I thought maybe you were just going to have the same thing, but then what was your coefficient of y? 24. Something got messed up along the way. Okay, so unfortunately, it was supposed to be positive. Michaela,
Oh, I thought I could
I'm sorry?
I didn't put 5 times 2.
Okay. So here's where some people went wrong, is translating the slope. The slope came out to negative 5/8. And then you have to somehow translate it to this. So how does this turn into this? The A must be the 5, and the B must be the 8. So you should have had 5x plus 8y equals C, and then use one of these points to find C. Okay? Sebastian. Okay, Kadir? Okay, comments, questions?
Can't you put the negative on the bottom for
Yes, you can. Okay, so the last idea is we want to be able to find a missing coefficient if one of them is missing. So, we're given a standard form equation except the coefficient is missing. We need to find it. Any suggestions? Any thoughts that immediately came to mind? Valerie? That's pretty brilliant of her. Yeah, we're given everything we need to use. If we plug this in place of x and y, and then solve for a, we will find out what a is. A times 3 plus 4 times negative 1 equals 2. For some of us, it might be more comfortable if I switch the 3 and the a so it looks like this. 3a minus 4 equals 2. How many steps will it take to solve that? How many steps will it take to solve that? Only 4 people know how many steps it will take? All my other students are actually doing the steps. Sebastian? 2. Actually, at this point, you should be able to do it with no steps. You should be able to look at it and know the answer. You should be able to look at that and know what a is equal to. We're doing nothing. What is a equal to? Go ahead, Sebastian, you're on a roll. A equals 2. A equals 2. And all we were asked to do was find the missing coefficient, so we are done. We found the missing coefficient. Does anyone have any questions on how that was done? Okay, I'm not sure if we need another example of that, but it would be the same. Don't write it down, but it would be the same if we were looking for the b. We would plug in x and y and solve for b. So you try one on your own and we'll see how we do. Find the missing coefficient. All right, so what is A? What is A? We'll start with Shannon, John, Kayla. Shannon, what'd you get? Okay. Okay. 1. So we have some disagreement. Anyone else want to chime in and work out the confusion? Davis? Yeah, A comes out to -4. A comes out to -4. Does anyone have any issues with that? Any issues at all? Because I heard some mutterings of something. Sebastian? That's right. So in this case, A is -4, but technically that's not standard form. So if we were to, what we would have to do is if we were asked to put this in standard form, then we would have to multiply the entire equation by -1 at the very least. But in this case, A was -4. So let me explain what happened. What happened was that these rules have been in existence for a while, but the publisher somehow didn't follow some of the rules. So you're actually going to see questions in the textbook and in the workbook that don't follow the rules. But you follow the rules that I'm teaching you. Because the rules exist on the EOC. When you take the EOC, standard form says A may not be negative. So, let me try and put everything in perspective for you from everything we've learned so far in Chapter 4. You do not need to copy this. But here's things you're supposed to know. Slope-intercept form, point-slope form, standard form. And then we learned a while ago that a vertical line will always be x equals some number, and a horizontal line will always be y equals some number. And those are actually standard forms of those types of lines. So for example, if you had x equals -2, that represents a vertical line that crosses through -2, and this is standard form of the line. Okay? So this is everything that you should already know. So let's practice on our own. Classwork is page 52. You're going to do number 22, 20, 16, 12, 11, and 4. That's 6 questions. Got a little less than 15 minutes. Number of text messages sent. So right here, how many text messages have been sent? Good. What is this? So right here, how many text messages have been received? Oh, okay. This line represents all the combinations. Every point on the line is a combination. Okay, pick up your colored pens. Here we go with number 22. Now, here's where the publisher messed up. Because the publisher wrote the equation in standard form, but that's not standard form. So what standard form should have been is you took that and then multiplied the entire thing times 100, and then it will become a standard form equation. And so that becomes 2x plus 7y equals 500, and that is technically a standard form equation. However, if you wrote this, I will accept it. Part B, you were supposed to graph. So here's what the graph should have looked like. The x-intercept, which is this point right here, is the number of text messages sent when you don't receive any. This point right here is the number of text messages received when you don't send any. This is a critical connecting piece. You have to be able to interpret the graph. Then it says list 3 other possible combinations, and all of a sudden my students have no idea what to do. A lot of you are missing the point. If I asked you to list all the combinations that were possible of text messages sent and text messages received, you'd be sitting here for a day and a half listing them. You'd have to write 200, 20, 175, 24, 150, 26, 125, 27. You'd have to list every single combination and all of them in between. So we don't do that. Instead, we write an equation that represents all the combinations. This is all the possible combinations, but so is this. A combination is a point on the line. We've talked about this before in the past. All of these are possible combinations. We've talked about this before. We talked about it when we talked about graphing using intercepts. Number 20. I did not go over how to do number 20. You were supposed to already know. It was actually something kind of thrown in. Number 16. X plus 2y equals negative 13. If you have any equation that's a multiple of this one, like everything's times 2 or everything's times 3, then that's also correct. Number 12. X minus 2y equals negative 7. Number 11, 4x plus y equals 26. And then for number 4, there was a ton of, just a zillion different possibilities. As long as you multiplied by a negative number, then you can mark it correct. So I apologize that I don't have any time to go over these with you, but if you have any concerns or questions, you come to my care class tomorrow morning. So for now, you need to draw a line across your paper. Your homework is on page 320, 8 through 36 even, and 38 and 40. And then to help you a little bit in preparing for your quiz, you need to do page 322, the ready to go on 1 through 6. That's 23 questions. And you have a quiz tomorrow on 5.1 to 5.4. We will actually not have a new lesson tomorrow.